Hi, my name's Stuart Lynch. In this video, I'm going to take a bit of a deep dive into SwiftUI ScrollView improvements introduced in iOS 18. Things just keep on getting better. So let's investigate each new method and modifier and see how it can help us improve our scrollable collections. I love getting your feedback, so if you enjoyed this video, please give it a thumbs up and leave me a comment below. Make sure you ring the bell to enable notifications and get notified whenever a new video is released. And if you want to support my work, you can buy me a coffee. A link is in the description. There is a starter project for this video, and you can download it from the link in the description. There are two branches, so make sure you download the starter project branch. The completed branch contains the completed source code for this video. You can just download and expand the zipped archive. You can see here that I have the project open and I'm currently running Xcode Beta 3, but I'm still on macOS Sonoma on this computer. The project has a number of different tab views with some content in each, and I'll explain each as I get to them. Last year after WWDC 23, I created a video that went over the changes to scroll views in iOS 17, and I'll leave a link in the description if you want to take a look at that video. Well, there are a number of new APIs again this year for ScrollView that give us a lot more options for creating interesting presentations for our collections. For the first four tabs, I'll be using a simple array of colors, and you can find these in the app data enum and the static myColors variable. Each of the examples will be presented on its own view, and if you run the app in the simulator, you can get to these by tapping on the appropriate tab. The first tab is on ScrollPosition, and as you can see, I'm simply iterating through each one of the app data myColors, using itself as the ID to present a rounded rectangle using that color and overlaying the color name in white. And you can see the views embedded in a navigation stack. There are three toolbar buttons that, when tapped, we want the view to scroll to the top, a random position, or the bottom respectively. And there's also a picker that allows us to select from 0 up to, but not including the number of colors in an array, so that when we select one, we'll want to jump to the display of that color at that particular index. To be able to scroll to a particular position in the scroll view, we'll need an instance of a ScrollPosition struct, which is a type that defines the semantic position of where a scroll view is scrolled within its content. And since this is going to change as we scroll, we'll make it a state variable. If I option click on ScrollPosition, I'll get to Quick Help, and if I scroll to the bottom, I can open the developer documentation. I always recommend that you do this as you're exploring new APIs. We see that this, along with a ScrollPosition modifier on the view, can control where a scroll view is positioned. And you can use the ScrollPosition type to scroll in a variety of different ways, either to an edge, to a view provided with an identity, or we can scroll to a concrete offset. So let's return to the view then, and we can attach the ScrollPosition modifier to the scroll view and bind it to our state variable. Well, the easiest is to scroll to an edge. In the action for the scroll to top, we can apply the ScrollPosition's scroll to function. And this has a number of options, one of which is an edge, which is an enumeration of 4 cases. These options are top, bottom, leading, or trailing, and of course this will depend on the type of scroll view you have. In our case, because it's a vertical scroll view, we can choose top or bottom. So let's choose top in this case. So if we manually scroll the scroll view and then tap on the button, it jumps immediately to the top. It's a bit too jumpy, so let's add an animation that will depend on the scroll position, and we'll choose the default animation. Well, we can repeat this process now, and we'll get a nice return to the scroll view to the top. Well, you can guess that for the action for the scroll to bottom button, all we have to do is change the case to bottom. You may have noticed that when we chose the scroll to function that there were a number of other options. One has to have an ID argument. Now, since our array of colors uses self as an identity, we could pick any one of these and have it scroll directly to it. For example, the fourth color is green, which is an index 3. So if we use the scrollTo function and provide an ID that is an index from the appDataMyColors array in the action, we should be able to scroll to it. Now, if we tap on that question mark button, it'll scroll to until the green view becomes in view. Well, we could pick a random element from the array and scroll to it. So in the action for the random scroll position, we'll find a random element. So we'll let random color equals appDataMyColors random element. Well, if we option click on random color, it reveals that it's an optional, and we'll need this to be non-optional. So we can use an if let here. And then we can use the ScrollPosition ScrollTo function using the ID that requires that hashable and sendable item, which is a color. So we can use it. And we can also print the string representation for that random color to make sure that we are getting what we expect. Now, each time we tap the button, the view scrolls either forward or backward until that color is in place within the view. The final option is to scroll to an offset. And since this is a vertical scroll view, the offset that we want is the Y offset. Now, each view is a color view that has a height of 300, and our V-stack has a spacing of 10 between the views. So we want to jump to an offset that will display the second image, the orange color. The offset would be 300 plus 10, or 310. The next one would be two 310s, or 620. Well, since we have a picker that provides us with an index, we can determine the offset by adding the height and space, which is 300 plus 10, so 310, and multiplying it by the index. So we can offer an onChange modifier for our bound picker color index. And then we can use the scroll modifier that requires a Y offset to scroll to 310 times the color index. This, however, must be a CG float. Now, when we pick one of these options, the view will scroll to that offset, which places that color at the index directly at the top of the view. Once the calculation gets too high to go beyond the height of the view, however, like when we get to index 9, we are at the bottom scroll position, so it will not scroll any further. So choosing 10 has no impact. Now there's one more modifier that I just want to mention here. The default scroll position is when a view appears and it's at the top. Well, if you're building a chat application, for example, or a social media app with a feed, you may want it to default to display the bottom of the scroll view. So you could attach a default scroll anchor to your view, and in a vertical scroll view, that anchor would be at the bottom. Let's explore some other new options on the next tab. The first thing I want to do is check out the Xcode documentation on ScrollGeometry. Now, it's a type that defines a geometry of a scroll view, and you can see that there are two functions that we can use, the onScrollGeometryChange and the onScrollPhaseChange. Both of these modifier functions can be applied to a scroll view, and they'll provide you with the properties of the scroll geometry, as you see. And there are 6 of these different properties that you can use when you're building your UI. And you might want to use this information to present other information or to change your layouts. So let's start with onScrollGeometryChange and see what we get for some of those properties. So you'll need to attach an onScrollGeometryChange modifier to the scroll view, and we'll need to provide some equitable type that we are looking to investigate. So for example, if we want to determine the current offset, we'll want the properties from the scroll geometry's content offset. So we'll need to specify it's a CG point type. And then we can hit enter on the closure to let Xcode expand for us. The first closure gives us the instance of the scroll geometry that we can call something like geometry. And then we can specify then that we want the geometry's content offset. And then within the action closure, we can expand that to give us an old value and a new value that we can use in our code. Both of these will be CG points. So let's just use the new value and print it out. Now, as I scroll, we'll see that the offset point is being printed to the console. And since this is a vertical scroll view, the X offset doesn't change. So we can specify then that we only want to look at the scroll geometry change, not for the full point, but rather just for the Y value, which is a CG float. So we can change here the type to be a CG float.self. And then we'll just use the geometry's content offset for Y. Now all we're getting is that single Y offset. Well, if you want to be able to take action on more than one property for the scroll geometry, you can create your own type. For example, we can create a struct called ScrollData that'll contain a property for every one of those different items in our geometry. But we must have it conform to the equitable protocol, and that's not a problem. Now, for convenience sake, I'm also going to create a second initializer for this struct so that I can assign an initial default value to the instance when I initialize it. So for our bounds, it'll be at .0, as will the container size, the content offset, the content size, and the visible rectangle. For the content insets, we're just going to use the default initializer for that. So now that we have this default initializer, I can create a new state property that we'll just call scroll data. That will be the initial scroll data. So we can now change our scroll geometry change to be for a scroll data.self and generate a new instance of this within the closure by then simply taking each one of the geometries by applying it to the instance of our scroll data item. And then in the action then, we can assign that new value to our scroll data. So now we have access to every single one of these properties. That way we can let our UI respond to these changes. And just to demonstrate this, how we can track this, let me create a text view above the scroll view. And I'm going to display the width of the scroll view. So that will be the scroll data's content size .width property. So we can see it displaying 361 here on the canvas. But let me run this in the simulator now. And I'm going to go to this tab, the second one. And I see the initial 361 on the iPhone 15 Pro simulator. But if I rotate the phone, however, I see that it switches to 702. So you may want to use this information to adjust the height or do something else within your UI. You'll have access to every one of the other geometries of the scroll view through this new scroll data struct that you can use. Now let's also look at the ScrollGeometryPhase function. So as we saw, there is that other onScrollPhaseChange method that we can use on a scroll view. It has two initializers, one that will provide us with an old and new phase, and another one that will also give us a context. So let's use the second one first so that we can explore all of the possibilities. I can simplify this a bit because this trailing closure here isn't necessary, so I'll just remove the closing parentheses. So let's just print out the old and new phases. And you'll see when I scroll in the console that we'll go from idle to interacting to decelerating and then back to idle when it comes to rest. So if we create a state property for our scroll phase, we can initialize it as idle because that's what it's going to be when we present our view. And then in the action for our modifier, we can assign the new value to it. So we'll always know what our current phase is by that state property. So then in our scroll view, we can set an opacity for the rounded rectangle based on that scroll phase. So if the scroll phase is idle, we can set it to, for example, 1. Otherwise, we'll set it to 0.5. And let's also gracefully do this with an animation, which will be default based on the scroll phase as the value. Now, whenever we're scrolling, it gradually fades, and then as it becomes idle, it comes back into full opacity. Well, if you check the documentation for scroll phase, you'll see that there are actually other cases of this enum, like animating and tracking. So you might want to use those as well and explore them. But there's one here, this option here, that's a Boolean property called isScrolling, which tells us if the view is actually scrolling. So I could have used that one instead here, where we set our opacity. If it's not scroll phase is scrolling, then we'll use 1, otherwise 0.5. So what about the context? Well, if we print out the context, we'll see that it has two properties, either geometry or velocity. We'll see that the geometry has exactly the same options here that we got from the onScrollGeometryChange function. So here we could have utilized both these at the same time. And then if we check the content velocity, we'll see that we either get a dx or a dy. And since this is a vertical scroll view, we can print dy. But this is an optional value, so let's only print it out if it exists. Now I find that this works best if it's demonstrated on the simulator. So let me run the simulator right now. And if I go to this tab, and if I scroll hard enough, you'll see the initial velocities displayed. The final new piece is scroll visibility, and there are two functions in this realm that we can use. So let's open the documentation page and go first to the onScrollVisibilityChange method. This adds an action that can be called when a view crosses the threshold to be considered on or off screen. The function will generate a Boolean value whenever the visibility of an object changes, and what this does is basically let us know the ID of the object that the scroll view settles on. Now there's a threshold that we can apply too. So 1.0 would be provide true when a view is completely in view, while 0.5 would provide true when it's only half in view. And 0.5 is the default, so we could leave it out. So we can then attach an onScrollVisibilityChange modifier to the item in our scroll view that changes, and it's going to generate a Boolean property that we can use in the closure. So you'll get a true value whenever that color by default has at least 50% of its content visible in the view, and false when it's not. And that item is our rounded rectangle. So as we scroll, the isVisible will change from false to true and false again. So let's create an optional state property that we'll call last visible color, and it's going to be an optional color that'll initially be nil. In our closure then, whenever isVisible is true, we'll assign that color to our state property. So then I can adjust the scale of our text overlay if I like, based on whether or not the current iterated color is the same as the visible color. And if it is, we'll apply a scale effect of 3.5, otherwise just 1.0. And we can specify an animation for that too, based on the changes of that last visible color. That's pretty nice. Well, the second function that we can use is an onScrollTargetVisibilityChange. And by the name here, we have to specify a scroll target layout. So we'll apply that to the entire VStack within the scroll view. And what we need to do by virtue of this function is to capture an array of all of the views that will be at least 30% within the view. So I'm going to create a state property called visible colors that'll be an array of these colors, but initially empty until the view loads. And then to the scroll view itself, we can apply the onScrollTargetVisibilityChange modifier that's asking us for an ID type. And for us, that's the color itself. And then we can specify a threshold. For example, for our 30%, it'll be 0.3. And that'll recognize the colors as soon as 30% of one of them is visible within the scroll view. And then the closure then gives us access to that array of colors that we can assign to our array of visible colors. Well, if we know this, then we can apply a transformation on the rectangle if it's contained or not contained within that array. So first, how about a rotation effect so that when the visible colors contains the color in the VStack, we'll set the angle to its identity, 0. Otherwise, we'll specify a rotation angle of 30 degrees. And we can also change the opacity for that same object. So if it contains, the color is contained within the visible colors, the opacity will be 1. Otherwise, it'll be 0.3. And of course, we should apply an animation for the value of visible colors with the default animation here. Now, as we scroll, those that are not more than 30% on screen are faded and rotated. So to finish off this video, if you're still with me that is, let me show you how you can combine some of these new techniques to improve the UI of a horizontal scroll view. Well, not too long ago, I showed you how to create a carousel view using a scroll view in one of my earlier videos. I'll leave a link in the description. Well, I've included some images in the assets folder for the starter project, and I've also created an identifiable struct called carousel image that has an image name property and an image title property. Both of these are strings. And you can see that in the app data folder. And in addition, I've created a static array called my images in the app data enum. That's an array of these carousel images. So in the final tab view here, we see that we have this horizontal scroll view using that container relative frame horizontal so that it'll only display a single image at a time. And the scroll target behavior is paging so that it always snaps to a full view. Well, the problem is that we don't know by looking at this view that there is more than one image. So I'm going to show you here how I can create a paging display now in iOS 18 using the new scroll view additions. So first, I'll create these two state properties. The first will be an array of images on screen, which is an array of carousel image, so that I can initialize it as an empty array. Of course, there will only ever be one on screen at a time because of our paging, but this is how we'll set it up. And then the second is going to be an instance of the scroll position. So a state property for scroll position. And then we'll need to specify that our H-stack is the scroll target layout so that we can now apply a onScrollTargetVisibilityChange where the ID type is a carousel image.self to get an array of carousel images on the screen. And then I should be able to just simply assign those images to the images on screen variable. Well, this complains because we'll need to go back to our carousel image struct and make sure that it is hashable, which it is because each of the individual properties is hashable. Now, if I do a quick check here and just print the array on the screen so that I can see which one is on the screen, I see that I have a problem. Nothing is getting printed out. And this is because in our previous example, the color was also the ID. But in this case, the ID is an int instead. So we'll need to, for our purposes of the images on screen, indicate that the ID for each one of our items in the VStack is in fact a carousel image. Now it's working. So now that we have that information in place, we can display our custom scroll indicators below this view. So I'm going to embed the scroll view within a VStack. And then as the second item in the VStack, I'm going to create an HStack. And within there, I'll use a for each loop to iterate over the app data my images to get an image iterator. And then I can create a circle where the fill is determined by whether or not the images on screen array contains that image. If it does, we'll specify a secondary color, otherwise a primary color. And similarly, we can set a frame width that is determined by whether or not the images on screen array contains that image. If it does, we'll set it to a width of 20, otherwise 10. And then to make this really nice, what we'll do is we will add some padding to the HStack. And then we'll add a background of a thick material in capsule. And let's animate this too. So we'll animate using a default animation. Now as we scroll, we'll see the position in the array of the current image. Well, we haven't used that scroll position that we created yet. So first we'll need to specify that the scroll position for our scroll view is bound to our scroll position state property. Now it looks like I have a typo here, but I'll fix this soon. So we can apply then an on tap gesture to each one of these circles. And then within the tap gesture, we'll use an animation block and then use the scroll position's scroll to for an ID of an image. Now, when we tap on the circle, it nicely animates to that image. Perfect. I do want to fix that typo now, though. Well, that's it for this video, and I hope that you've learned something new that you can use in your projects going forward as you adopt iOS 18. If you've enjoyed the video, please give it a thumbs up and leave me a comment below. And be sure to subscribe to my channel and enable notifications so that you are made aware of new videos that I release. But also make sure that you download my free channel listing application so that you can search for and find content from any one of my over 300 Swift and SwiftUI related videos. Thanks for watching.